So once again, my name is Dennis Burrell with Ventev Infrastructure, and the next area that we're going to talk about is street furniture. So it's like, oh, what is street furniture, right? So pretty much street furniture is light poles, lamps, bollards, anything like that where we're trying to put some Wi-Fi or provide Wi-Fi usage in areas where they can't get anything as far as any not access points, but any antennas, and they want to utilize what they currently have constructed or that's already up as far as the lights and bollards. So the first one I want to go over with you is a light bollard antenna. And basically what this is just taking the light bollards that provide light along the walkways, and you're providing Wi-Fi for them. We've come up with a dual band design, 6 dBi design, has 60-degree vertical beam width and a pseudo omni horizontal beam width to go inside the light pole. So we're working. We have a lead customer that we did a design for that'll be and putting these in their outdoor area, and their bollards are concrete bollards. So we took their bollard and we actually designed an antenna to fit into that structure. And by pseudo omni horizontal beam width, what we have is we actually have 4 sets of directional antennas that we feed through a splitter to get an omni pattern out of directional antenna. So that's what I mean by pseudo omni. So instead of directional, now you have an omnidirectional pattern for the bollard antenna. We're also working with the bollard manufacturer to come up with a standard product for one of their products that they'll be releasing later this year in the US. And that one will actually be more of a directional, because their light is directional lighting. It's not full 360 lighting. So we're working on something like that with them as well. So the good thing about this is now you have some areas where you typically couldn't get Wi-Fi, and now you have the ability to provide Wi-Fi. So you have your outdoor areas, you have your amusement parks, and areas where they typically couldn't have Wi-Fi, but they want Wi-Fi. Now you have the ability to provide Wi-Fi for them. The next one is light pole antennas, and pretty much what this is putting an omni antenna on the top of a light pole or a light fixture or just the pole itself to provide omni coverage from a light pole in the area. We've come up with a design that fits a 4-inch diameter pole where the antenna just snaps right on the top, and then it's connected to the pole, color matched to the pole so that you wouldn't even know that it's an antenna. Then the cables run down the bottom of the pole, down to the pole, to the base of the pole where there's either an access point or an enclosure where the access point fits and the cables connect to the access point. And this is one of the prototype units. It was a gray pole. Of course, this is not the scale. These will be 12 to 15 foot tall light poles, and then the antenna just fits on top of it and snaps in either with rivets or with screws.
Hey, Dennis?
Yes.
This one is prototype, but the ones prior, are these all prototypes?
Yeah, this is a prototype unit. This is getting ready to go into production probably within this quarter. The light bollard will be available in next quarter, and then.
So if these get sunk into concrete, do they get lifted out of the concrete so you can put an AP inside, or do you concrete the AP in?
Well, so the way that they're looking at them is that they're coming out the bottom with the enclosure somewhere near where they'll have the access point.
And they cable through the concrete?
Yes, and they cable through, yes.
Copy.
Mm-hmm. And then what we have are light globe antennas. Now what this does is you have an existing light fixture outside and you want Wi-Fi. And if you can see where the red circles are, those are actual antennas that we've fixed to the actual light fixture. We call them our P-Sign or our Mercedes-Benz antennas. And what you have is you have those affixed to the legs of the pole, and the cables go down through the arm, down to the pole, and then down to the bottom where they have the access point. This is a dual band design, 3.5 dB of gain, 40 and 30 degree vertical beam widths for 2, 4, and 5 respectively, a pseudo omni horizontal beam width, and then like I said earlier in some of the designs, we always use low loss cable because we have a long cable length. So we want to use low loss as much as possible to limit the further losses and keep some of the gain of the antenna. We're actually working with the manufacturer of these light globes, and this is actually going into one of the high-end malls here in California, and we're working with the manufacturer, and we've standardized a product for this specific light globe that'll be released later this year.
How are you coloring the elements themselves? Are those exposed elements or the elements inside of the triple?
Are they covered in PVC?
No, they're actually exposed. They're exposed elements, but they're painted and we have humisil over them so that you won't have any issues with the elements. And when that question came up, so what we wanted to do was we wanted to test. So we went and we took that existing antenna without any paint or any humisil on it, and we took it and we wet them with water, and the performance, just as far as the return loss and the visual and the radiation as far as at 2, 4, and 5, just totally distorted the antenna. Then we took the existing set with the paint and the humisil over them, put water and everything over them, and there was no change. So they're environmentally sealed so that they'll perform out in the elements.
And they come that way, or you obviously would buy the light globes with. How do you package that for sell? Do you package it with a light globe?
So it's one of two ways. Since the mall that we're working with is a retrofit, they'll receive them like this, and they come with clamps, form the clamp to these legs. So it fits up and clamps to the legs, and then the cable goes through the arm, down the pole, and then they're putting their access point next to the poles. They have bushes around all these poles. They're putting the access point in an enclosure next to the poles. Then once we release the product with the manufacturer, the light globes, it'll come like this. The only thing you have to do is pretty much just plug up the antennas. Yes.
Is there anything that you don't put antennas in?
Hey, we're trying to think outside the box. So if there's
Clearly.
a problem with Wi-Fi that can be solved, we try to solve it.
Yeah, and inside the box.
And
yeah.
around the box, and through the box.
Hey, Dennis, on these outdoor applications, for the people that you're talking to about, actually employing them, do you get the sense that any of them are talking about home running each and every AP? Do they talk about doing mesh? I mean, I know it's got nothing to do with your application, but you get a sense of how people envision using these outdoor
Yes.
things?
Specifically for this application right here, going back to the question about location-based and CMX, this is specifically, they want to be able to identify the user, that whatever user client device walks next to a specific store, and then locate and then start pushing coupons or things to. So they're specifically for this one, they're all about CMX and location-based services. It's an outdoor mall, so they already have antennas up in the facades of the stores, but they don't have another third antenna for triangulation. They only had the light poles, so we came up with this design for them so that they could do the triangulation for the location of the.
But what I'm asking though is each one of them, not that, again, it doesn't really matter to your discussion, but I'll just finish up what I was trying to get at, is, do you know if they see each AP actually having a home run back to a network switch? Are they tapping into your local PoE and doing mesh backhaul?
I'm not sure.
Okay.
Well, I think these are all PoE going into